Joining me now is Distinguished Professor of Sustainability at the University of California, Berkeley, and Senior Advisor for Energy Innovation at the U.S. Agency for International Development, Daniel Kammen. So is this true? Immediately and forever if we're able to commercialize this?
Well, as soon as we commercialize it, but there's a lot of roads between here and there.
Yeah.
But this is the landmark achievement to actually produce fusion and to get significantly more energy out. This is really the holy grail on the science side. Now we've got to move into the energy and materials side.
So it was a big effort to do this with some pretty high-powered lasers, and they were only able to do, explain it to me, but as I understand it, they were only able to do it once in this setting. And in order to actually power an energy grid, you need it to be ongoing and continuous, right?
Yeah, you're exactly right. But this is really the key thing. It was only designed to be a one-time shot. And the way this particular fusion was achieved was by having an eraser, pencil eraser sized gold foil cylinder with the hydrogen inside, deuterium and tritium, two flavors, two isotopes of hydrogen. And so what they did was they focused the lasers, they received a burst of X-rays, and that generated enough energy density that the hydrogen atoms began to then fuse. And that process done once is the breakthrough that no one's been able to achieve, not through this laser method or the other competing method, which is a magnetic bottle that holds the plasma in place. So now that we've done it, now the question is, do you inject a whole series of these pellets one after another? And I'm expecting in the coming months, there'll be announcements from the other side, from the magnetic bottle community. So it's a really exciting science on a very clear path now to energy production.
So we've done it once, and the question, of course, is when can we do it a lot of times? Do you have a guesstimation for a timeline on when this could be deployed functionally in our energy grid as electricity?
Well, this is still the science, and I know everyone wants to jump to when will there be a fusion power plant in my backyard or nearby. This needs to go exactly the way you said. When you do one pellet, now we'll do a series of pellets, and the Livermore team is ramping up to then be able to do that, hopefully this coming year, but we'll see when that happens. And then it's really a story of material science and the development of the hardware so you can do it continuously, and then you have this clean energy supply with unlimited fuel, but there's a lot of engineering steps on the way to get there.
Well, give me a good guess. A decade, 50 years, 100 years?
Well, it's certainly not 50 years, and it's certainly not 100 years. A decade is going to be if what Secretary of Energy Granholm said this morning, and that is this is a triumph of 60 years of big science research done at a national laboratory with big teams. And the excitement here is that now that this has happened, under an administration that has invested heavily in science, not only the Inflation Reduction Act, but also the CHIPS and Science Act, re-onshoring technology here. This is the ideal moment to really excite that next generation of engineers, the scientists, of people looking at the social justice side of clean energy. That's really what we're trying to build, and that's why it's so exciting to see this now. So I would say a decade is a good number, and if everything falls right, we'll see.
I know climate reporters and climate scientists are being a little cautious here, saying that while this is wonderful, the timeline that it would need to be implemented is just not short enough to start rolling back some of the problems we're facing with climate change.
Well, that's also right. We really need to decarbonize our economies, not just in the U.S., but around the world by 2050. And it would take a huge series of engineering investments and successes to get fusion operational in large scale before then. But I like to say that in 2070, when unfortunately I fear I'll be gone, that I think the world will be 70% or so powered by fusion energy. But half of it will be 93 million miles away, meaning solar power, which is fusion energy, and the other half on the surface of the Earth. So it's a big engineering road, and we can't take our attention away from deploying more renewable energy, more energy storage, more energy efficiency. But this gives us a huge partner that is on the way.